Hello everyone and welcome to this GREATsoils webinar on managing soil health using organic manures, which will be presented by Dr. Martin Wood of Earthcare Technical. GREATsoils is a programme of work funded by AHDB Horticulture, including projects CP 107, 107B, 107C and 107D. The Project 107B, Growing Resilient, Efficient and Thriving Great Soils, is delivered in partnership by Earthcare Technical Limited, the Organic Research Centre and the Soil Association. This webinar qualifies for one basis point. If you would like to register for that point, please let us know by messaging us. Okay, if everyone's ready, then over to you, Martin.
Thank you. Hello everyone and welcome to this third webinar in a series of 4 on the subject of soil health. And it's a topic that's fundamental to the sustainability and profitability of the agriculture and horticulture industry. My name is Martin Wood and I work for 20 years in the Soil Science Department at Reading University, and for the past 10 years I've been working with colleagues in Earthcare Technical doing knowledge exchange with farmers and growers. And one of the things that struck me talking to growers over the past 12 months in particular is how this topic of soil health is really becoming much more important to growers. So the aim of this project is to inspire you, the growers, to develop your ability to assess the health of your soil. And secondly, we want to provide you with practical solutions to improve the health of your soils. Today's subject is on how to manage your soil health using organic manures. And there are 6 topics that I want to cover. The first one is really asking the question, why do our soils need organic matter? And secondly, I want to go on to look at the types of organic manures that are available and how much there is out there. I'm going to be focusing then on 2 particular organic manures: compost, which has been around now, I suppose, in significant quantities for the past 10 to 15 years. And we know a fair amount about compost and what it can do for soils. And then I want to turn to digestate, which is a new material, which has only been around for the 2 or 3 years, probably in significant quantities. So I'll be talking a little bit about digestate. Then I want to go on to look at best practice and how you can get the most out of organic manures, compost and digestate, and looking at best practice. And finally, I want to bring together some examples of what we actually know about the benefits of using these materials on soils in relation to soil health. So there are 3 slides coming up on the background question as to why we actually need to think about organic manures and organic matter in soils. And the first one is one that really shows the average wheat yields in the UK over the past 120 years, but particularly I want to focus on the last 50 years from 1945 onwards, where you can see this steady increase in average yields of wheat. Year on year, there's been increasing yields. And of course, this is due to the availability of these new innovations in agriculture, lime, fungicides, herbicides, and the availability of fertiliser, particularly for use in springtime. But when we look at the far end of the graph, we can start to see that yields have started to plateau. We're not getting the continual increase in yield despite the use of the inputs. And one possible explanation for this is the poor structure of soils due to decreasing levels of organic matter. So soil physical properties are starting to play a role in limiting yields. So that's one bit of background information. And the next bit of information is really the documented evidence from soil analysis, which clearly shows that soils are losing organic matter. They have been losing organic matter, and documented decreases in England and Wales for arable soils show that they've been decreasing, for example, from 3.4% on average to 2.8%. So that's a 0.6% decrease in organic matter over a 15-year period. And we know also that when organic matter levels decrease, and people have suggested a critical value of 3.5% organic matter, then soils can be prone to structural deterioration. And the third reason why soils need organic matter is because organic matter really lies at the heart of soil health. It serves as this store of crop nutrients, major nutrients, minor nutrients. It's an important store of carbon. At least half organic matter is made up of carbon. It improves soil structure with all of the benefits that follow from that. For example, increasing water holding capacity. And it enhances the biology in the soil, both the activity of organisms and also the diversity of the biological population. And this slide, which shows images of soil under the electron microscope, so under very high magnification, but really sums up what we mean by soil health. We can see clearly bacteria and larger organisms such as amoeba existing in soil, so these are actual soil samples in situ. We can see organic matter, and we can see the structure of the soil brought about by that organic matter. We can see spaces and solids, and all of this is what we mean by soil health. Now, we're at a very interesting time in terms of soil health, because not only have we got these observed problems with soils, we've also got opportunities. And there's a couple of opportunities that I've highlighted here. There are new sources of organic materials, of organic matter that have become available. Recycled organic materials such as compost. We've also got the increased interest in green manures and cover crops, plants such as oats and phacelia. And the fourth webinar in the series will be focusing specifically on this topic of green manures and cover crops. Just to briefly summarise some of the considerations that you might like to think about in relation to cropping and tillage before I move on to organic manures. Firstly, cover crops and green manures, and more people we know are looking at using these materials within their cropping systems. Traditionally, grass lays have been an important component of maintaining soil health, soil fertility, and break crops are established and as an important component of soil management. Deep rooting rape, providing plenty of stem and root material, the fibrous roots of oats, also providing good levels of organic matter return. So there are crop options, but also there are tillage options. The increased interest in minimum till and low tillage. The idea that the more we till the soil, we more disturb the soil, the more we encourage the burning off of organic matter, its conversion into CO2, so it's lost from the soil. And then the interest in and the move towards more incorporation of straw. The benefits of incorporating straw after cereals, for example, rather than baling it and removing it from the soil. So a whole number of options there which can help improve soil health. But what I'm focusing on in this webinar are the external sources of organic matter, materials that you might bring in onto a farm to improve the soil. I'm focusing on four main types of material. The traditional source of organic matter, livestock manures, that includes solid manures and slurries, and we estimate there are about 90 million tonnes of that material in the UK. The use of sewage sludge, also known as biosolids, provides another source of recycled material which goes to land. That's a pretty well established industry now, and routes to land are well established, about 3 to 4 million tonnes of biosolids. Compost has been increasing, although it's starting to tail off a bit now in terms of the amounts, and there's probably about 2 million tonnes of compost produced each year in this country. And a very rapid increase over the past 5 years in terms of the amount of material produced from anaerobic digesters, probably up to around about 2 million tonnes, the latest figures from RAP on the amounts of digestate that are being produced in this country. So we've got four main types of materials there, and the two that I'm going to be focusing on are the new ones, the compost and the digestate. The first year, I just want to explain clearly what we mean by these two materials. What is compost and what is digestate? And I want to start by looking at compost, because they're produced by quite different processes. Compost is produced by an aerobic process, a process that encourages the introduction of air into organic materials. It involves the feedstocks, probably green waste in particular, the kind of collection, green waste collection, garden waste, park municipal waste. That's the material which will end up in windrows, open windrows, and sometimes food waste is mixed in with that material. If food waste is included in compost, then the animal byproducts regulations are triggered, and there are special treatment conditions required, enclosing the material, for example. The material is sorted, shredded, and then with compost, the whole philosophy is to turn the material to make sure that it is well aerated, that the microorganisms within that material are exposed to air and they can get going and decompose the material. This leads to the generation of heat, and by actively managing the material, temperatures can rise up to approximately 70 degrees centigrade. And if it's maintained, for example, if the material is maintained at that temperature for an hour, then you get sanitization of the compost. The next stage would be for that material to be stabilized, effectively the process of humidification that goes on, and finally screening, ready for application to land. And a suitable screen size for agriculture might be something like 15 mil screen size. So that's a very rapid run through of the process of composting. But it's important to bear in mind that you should always, if you're thinking of using compost, you should always look for quality compost. And the way to ensure that you have access to quality compost is to look for material that meets the PAS 100 specification. That's a very detailed specification both for the production of compost and for final product analysis. There's over, I think, 60 different analyses which are carried out on material before that is certified as being fit to go to land under the PAS 100 scheme. And there's an example of some good quality compost to the right. So always look for PAS 100 quality compost. Now let's just think about digestate, how that's produced and why it's different from compost. And the fundamental difference is that digestate is produced by an anaerobic process. That's a process that excludes oxygen from the microorganisms that are responsible. The feedstocks will include waste from food production, could include slurry, and also crops are grown specifically for use in anaerobic digestion. So a liquid material which will be contained within a digester will include, if it's PAS 110 certified compost, will include a pasteurization stage, 70 degrees for 1 hour, very important in terms of control of pathogens, followed by a mesophilic digestion stage, probably 30 to 40 degrees. This generates the biogas, which is the key economic incentive to use AD, used for energy production, but also most of the material that goes into a digester comes out the back end. This is what we refer to as the digestate, which can be used in agriculture and horticulture. And exactly the same as with compost, there is a specification for quality digestate, PAS 110, and again, anyone who's thinking of using digestate should make sure that they're using PAS 110 certified compost, digestate. So having described the materials I want to talk about, let's now look at some of the properties of these organic manures. And if our main aim in using organic manures is to increase soil organic matter, then the first thing to look at is the organic matter content. How much organic matter is actually applied to land when we use, and in this case I've given examples of 3 organic manures: farmyard manure, green waste compost, and whole digestate. Organic manures fall under the NVZ rules, and so the application rate that you are permitted to use will depend on the dry matter content of the material and also the total nitrogen content. So this table is based on typical total N contents for these 3 materials. Manure at 25% dry matter, you might be able to apply 42 tonnes per hectare. That would supply 5.5 tonnes of organic matter. Compost, a typical application rate of 33 tonnes per hectare, would deliver 4.5 tonnes per hectare of organic matter. But digestate, only containing about 3% dry matter and a relatively high total nitrogen content, you might apply 50 tonnes or cubic meters per hectare, and you'll be applying less than 1 tonne of organic matter per hectare. So digestate, clearly from these figures, is not a good source of organic matter compared to other organic manures. It's good for other things, but it's not a good source of organic matter. Now, there are different types of organic matter. Organic manures contain different types, and one way of analysing organic manures for their lignin, or for their stability, is to measure the lignin content. And this graph shows the lignin content of 3 different materials. I'm going to focus on the livestock manures and the compost. The manure contains about 30% of the organic matter in the form of lignin, and the compost a much higher percentage. Over 70% of the organic matter is in the form of lignin. Now what that means is lignin is a very stable form of carbon, and the process of compost production, that thermophilic process, accelerates the production of humus in the organic manure. So effectively compost is a humified material. And what that means is that organic manure will hang around in the soil much longer than the equivalent amount of livestock manure. And we know from trials that ADAS, for example, have carried out that 6 years of compost addition to a soil can be as effective as 18 years worth of farmyard manure in terms of building soil organic matter. And the reason for that is that the compost contains this stable material. Organic manures also, of course, supply a whole range of nutrients, major nutrients, minor nutrients, and I've included some typical data here for 3 types of organic manure: farmyard manure, green compost, and whole digestate again. And the first thing to focus on here is the farmyard manure, showing the kilograms per tonne of phosphate and potash, reasonable quantities of both of those nutrients in farmyard manure. But the variable amount of readily available nitrogen depends very much on the type of manure, how it was managed, etc. Green compost, again, serves as a good source of phosphate and potash. And most of that potash will be readily available, and probably half of the phosphate will be available as well. So good P and K in compost, but rather less P and K in digestate. And in green compost, we've also got a reasonably good level of total nitrogen. But notice here that the readily available nitrogen in compost is very, very low. There's virtually no available nitrogen in compost that will become available to crops in the season of application. So high total nitrogen, but relatively low available nitrogen. Contrast that with digestate, a good level of total N, and 80% of the total nitrogen in digestate is readily available, pretty much all in the form of ammonium. So you can see, again, a very big difference between digestate and compost in terms of its nutrient content and availability. That point is just emphasized by the next slide, which shows in the form of a pie chart the proportion of the readily available N to total N in digestate, 2 forms of slurry, pig slurry and cattle slurry, showing that that goes from 80% down to 45% for cattle slurry. And on the second row, we can see the 2 types of compost, green compost and green food compost, with very, very low readily available nitrogen contents. So all of those materials in the top row would fall into the closed period for MBZ rules, could not be applied during the closed period, whereas compost could be. Now, in terms of using compost and good practice, RAP have produced a recent guide for farmers and growers, and I've included the link to that guide underneath the image here. And that provides a summary of the key points which you need to consider if you're going to think about using digestate and compost. And the questions which this guide considers are, firstly, do I need any kind of permit or license to apply these materials to my land? And the answer is almost certainly yes, but the details are given in that guide. Secondly, how should I plan my applications of compost or digestate to fit in with the fertiliser recommendations? What about use of these materials on organic holdings? What about using these materials in NVZs? And then some practical advice on how to apply these materials. So there's a very useful source of material there which you can refer to. Also within the guide is a matrix, a kind of a framework which shows how these materials can be used with different types of crops. And I've concentrated here on the fresh produce example because that's the one of greatest interest today. And just to illustrate the principle of this matrix, it's really analogous to the safe sludge matrix, which was developed several years back now for the use of sludge, sewage sludge on crops. We have down the left-hand side a group of crops, which are actually vary in their sensitivity to pathogens. And along the top, 4 different types of material. Pasteurized digestate, digestate which isn't pasteurized, green compost, and then green food compost. And you can see that all of those materials could be applied, but could only be applied before drilling or planting to all 3 groups of crops, provided they were, in the case of digestate, pasteurized. But digestate which isn't pasteurized should not be applied to group 1 and group 2 crops. So what are those groups? Let me give you some examples of the types of crops which fall into those categories. And of course, the caveat with all of this is that you should always check with your customer, your buyer, before using these materials to check that they are happy that you use them on your crop. But within the Renewable Fertiliser matrix, group 1 crops, the most sensitive crop to potential contamination with pathogens, are those which are eaten raw, have no protective skin. So celery, leafy salads, herbs would fall into that category. Group 2 crops are those which are eaten raw, but which do have a protective skin, which could be peeled, and which grow clear of the ground. So carrots would be one example, strawberries another, and apples is another example. And then the third, the least sensitive group of crops, are those which are always cooked before being consumed. Potatoes, runner beans, for example. So having considered the background to these materials, what they are, what you should think about before using them, I'd now like to turn to and look at some of the evidence that shows how these materials can benefit soils and crops. And I'm going to draw some information from the trials which were RAP funded from 2010 to 2015, the so-called DC Agri trials, which were a series of field trials across the UK, England, Scotland, Wales, where a number of organic materials, including compost and digestate, were trialled on a number of crops on a number of different soil types. And again, there's a recently published summary of the outputs from this material, the key findings. I've included the link here to that summary report. So the first point to consider is compost as a soil improver. How good is compost as a soil improver? Well, we know that it's a source of organic matter, and we know that there are benefits that follow from that. We know that it's got good fertiliser replacement value, pK, some magnesium, some sulphur, and some slow-release nitrogen. And it also contains trace elements such as copper. Compost also has a small liming value, equivalent to about 1 to 2 tonnes per hectare of lime. So that can be useful as well. So let's now look at some actual data on what compost can do for your soils. Here's some data from a project carried out by ADAS, and it summarises the increase in soil organic matter, which has been averaged across 9 trial sites over a period of after 10 years of compost use. And you can see here that the average increase, and I stress it's the average, has gone from about 2.5% up to about 2.8, 2.9% organic matter. So on some sites, increases will have been greater than that. On some sites, it may not have been as large as that. But that gives you an average feel for the benefit of compost. About 0.5% increase over 10 years on average. What that means then in terms of the physical properties of soil, the soil structure, one way of measuring that is to measure the so-called bulk density of the soil. And a soil which is more compacted, is harder, will have a higher bulk density than a soil which is loose and more friable. And this is a trial that was carried out by Enviros in East Anglia, where there were 3 treatments in this trial. The first one involved adding no fertiliser at all to the crop. That's the brown bar. The red bar is where NPK fertiliser was applied according to RB209. And the third treatment, the novel treatment, is where compost was used. But because compost has such a small amount of readily available nitrogen, nitrogen fertiliser was used at the recommended rate to complement the compost. And you can see that after 7 years of applying 30 tonnes per hectare of that compost, there's an 8% decrease in soil bulk density when the compost was used. And I've actually walked across those plots and you can actually feel it under your boots. You can feel the springiness in the soil on those plots. It was really striking. That was a relatively light soil. Another effect of compost, again on lighter soils, this is a sandy loam soil, is that compost will tend to make the soil darker. And that can have some useful benefits as well, because a darker soil will retain more of the incoming solar radiation. A soil that's been treated with compost for a number of years will tend to warm up quicker in the spring. And that, of course, can lead to quicker germination of seeds. So that can be a benefit as well. Now, we talk about organic matter and biological activity in the soil, but here's some actual data showing that compost, again, 30 tonnes per hectare for between 8 and 10 years, actually does increase biological activity, here measured in terms of the amount of soil respiration, which is one of the methods that we're looking at within the GREATsoils project as one of the novel ways of assessing soil biology. But you can see at the Loudham site, and the green bar is the NPK fertiliser, the blue bar is the compost treatment. There was a small increase in microbial activity, and at the Gedgrave site we had a significant increase in microbial activity after using compost. So that's reassuring. We'd hope that would be the case, and it actually is shown by the data. Another of the techniques that we're promoting as part of the GREATsoils project is the use of visual soil indicators. It's a very easy way in the field of getting a quick estimate of how your soil is. And you can see from these two images of on the left, the NPK fertiliser treatment, and on the right, the compost with the nitrogen fertiliser, you can see a real improvement in the soil structure in terms of the number of those small aggregates on the right-hand side, much better tilth of the soil, the kind of things that you notice when you're ploughing or cultivating a soil, the way the soil falls, the way the soil breaks up. This is a clear improvement on the soil from the use of compost. What does that mean in terms of crop yield? Well, here's a crop of onions that was grown as part of that trial. And in a dry year, here's the image of the NPK fertiliser on the left and the treatment that included compost on the right. In a dry year, it had a big impact on establishment of the crop. And that led through to an increase in yield of 6 tonnes per hectare, increase onion yield from the compost treated plots, which was equivalent to about £800 per hectare. So good return on that compost. So what about digestate? What are the benefits of using this material? Well, the key feature of digestate is that it's a really good source of readily available nitrogen. It's more richer in ammonium than pig slurry. So that's good in terms of its fertilizer equivalent properties. This also means you've got to handle it very carefully to avoid any environmental harm. It also contains other nutrients, P, K, sulfur, trace elements. But it's really managing that readily available nitrogen which is the key consideration when using digestate in agriculture. So the method of application is important. Trailing shoe is useful. Injection is good, because if you get the digestate into the soil, then you'll reduce the potential losses to the air. Timing is important as well. With trials on cereal crops, applying digestate in the autumn to autumn wheat, probably as little as 10% of the nitrogen in the digestate was acting as a fertilizer. 90% was potentially going to be lost from the soil, either through ammonia to the air or nitrate leaching. Spring application, far better, far lower losses, much better use of the ammonia in digestate. So to get the most out of digestate, both in terms of its fertilizer replacement value and also in terms of minimizing potential environmental harm, a lot more effort and thought has to go into the application method and the timing. So to summarize, quality compost, and by quality compost I mean PAS 100 compost, is an excellent source of organic matter with all the benefits that are associated with that. The improvements in soil structure, improved biological activity, and it's long-lasting. It's a good source of P and K, and although there's no available nitrogen for the crop in the first year, with repeated application year after year, after 3 or 4 years, some nitrogen will start to come out of that compost. Quality Digestate, and again by that I mean PAS 110 Digestate, is a good source of readily available nitrogen, but it's not a good source of organic matter. So the impact of digestate on soil health is going to be less than that of compost. As part of the Great Soils project, we're starting to produce various bits of information for growers. We've already produced an information sheet which summarises the soil assessment methods that you can consider using, ranging from simple in-field spade tests, visual soil assessment, through to standard laboratory tests and innovative new laboratory tests. And that's available for download from the AHDB Soils website. We're also producing a series of case studies, and the first one is about to come out. It's been produced, and it's on this very topic of compost and soil health. So that will be available soon, again, on the AHDB Soils website. The Great Soils project, Growing Resilient, Efficient and Thriving Soils, has a number of activities, of which these webinars are one part. I've mentioned some of the publications. We're running workshops around the country with growers, and we're involved with field labs through the Innovative Farmers. So that's the end of the webinar. If you'd like further information or to keep in touch with the Great Soils programme, then please get in touch either via email, follow us on Twitter, or visit the Great Soils website. Thank you.